completely flipping this room, which means when we close the door,
Okay, we're going to get started. Everybody is lined up in their proper order, and I'm going to be last. And I think, I did have an announcement from Elaine. Tomorrow is the due date of the DDAP Step 1s, and she said there's 5 people who still have to finish their stuff on Inspires. And so, there she is. Did I get that right, Elaine? Elaine? Did I get my announcement right, your announcement right?
mostly done.
5 people, mostly done, get done.
Release to org. I just said it that way.
Wow, release to org. That's like release the hounds. Okay, everybody's on mics. I think we could go ahead and get, sorry, we have intro.
Hello everyone and welcome to the PSI Retreat Lightning Rounds. This morning we are going to have a myriad of scientists who each have exactly 1 minute, no more. If they go long, they shall be hooked off the stage. Get all the science, all the education, all the technology, all the communication right here at the Planetary Science Institute and watch it live on twitch.tv/CosmoQuestX. Without further ado, I need to swing the camera. Here we go. You have a mic. You do.
So, my name is Elizabeth Adams, and I'm going to take you out of the solar system, somewhere very far away, and also really close to ultra-short period exoplanets. These are planets that are in crazy, stupid orbits. That's the technical term. Their periods are a day or less. Their distance from their stars measured in like a few solar radii. And we are looking at ultra-hot Jupiters in particular because they go out to about 19 hours and they stop, presumably because it's really unstable for a Jupiter-sized object to be that close to its star. And before it either inspirals in and crashes into the star or loses all of its gas and becomes a tiny, small little core of its former self. So what we are doing is using test data to distinguish between binary stars, which are everywhere, and ultra-hot Jupiters, and there's some stuff that I'm not going to talk about because, like these planets, my time is up.
Hello, my name is Gareth Morgan. I'm based in Washington, D.C., clouds over Congress, readings that way you want. So I'm involved in both Mars and the Moon. The main sort of highlights, I guess, of this year has been getting in the extended mission proposals for both MRO and LRO. But by far, most of my work has been concentrated on the SWIM, or the Subsurface Water Ice Mapping project, which I lead with FAN and a lot of people here at PSI involved with. We've completed that mapping of the Northern Hemisphere, and all our data sets are available through the PSI's website. So I encourage you all to look at that, use that, involve it in your research. Please ask us if you have any questions about it. Hopefully there'll be an extension. That's another ongoing story. Also, of course, still working on the Moon, so I've been doing mapping with Mini-RF to look at young Mars stratigraphy, and also working with other colleagues here at PSI to do mapping work of the near side of the Moon using both Earth-based radar and also Mini-RF as well. Thanks very much.
Oh, it's gone funny. Okay, so this is my first lightning round. Be gentle with me. I'm Gretchen Benedict, senior scientist. I'm based in Australia. We came up with an automated crater detection algorithm, which we applied to the THEMIS level resolution. We tested it on that. We've now applied it to CTX, 6 meters per pixel. I have a poster out there somewhere, and if you want to talk to me about it, we've basically counted 17 million craters on Mars at CTX. From 40 meters to 50 kilometers, and we've learned some really interesting things about Tucson crater, which this is not. This is Mojave crater. But basically, this is just an image of every crater we've counted, and what's really interesting is that you can see the rays coming away from the crater, and what we've discovered is that they go a lot farther than we thought they did. Thank you.
My name is Jeff Morgenthaler, and my bread and butter is this little 14-inch telescope called the IO Input-Output Facility, IO. I use it to study Jupiter's magnetospheric reaction to an outburst of material coming from Io's volcanoes. Large volcanic eruption was seen in 2018. I was publishing AppJ letters earlier this year. Oh no, my movie isn't running. You're supposed to be seeing a really nice movie there of all the images that I used for this data set. Other cool things that you see are Mercury, the sodium tail of Mercury, letting us study Mercury's atmosphere, and comets taken with a UV satellite. That's a 1-degree field of view. That's a cometary cone. And that's all I have time for.
Hi, my name is Yuki Yamashita. I do nuclear spectroscopy.
Hi, my name is Beatrice Muller. I'm a senior scientist here in Tucson, and I study mostly comets. I'm interested in all these things here. We concentrated last year on the 4-star P comets. This is 41P, 45P, 46P. They came very close to Earth, and we have tons of data. So we put in an SW for the analysis and hope we get it, that we can do all this cool stuff. One of my favorite objects, comets / centaurs, is SW1, which is now the target of really cool discovery mission proposal. Ask Laura Whitney if you want details. I also work for PDS, and I'm mostly here to help you put in your asteroid and dust data into the PDS through OLAF, and I do data for the small bodies image browser as well.
Hi, I'm Francois. I have a dual role here at PSI. I manage our scientific software licenses. So if you have any questions about those, feel free to come ask me about that. I also provide research support to various members of the science staff here at PSI. And in relation to the second, earlier this year and late last year, I lead authored 2 papers that were published. One is in regards to the geology and erosional history of Apollinaris Mons volcano on Mars, the geologic map shown on the upper left, and then also a second paper on valley network morphology and Greater Mariana Platinum on Mars, which is the map on the lower left. And in both of these studies, they utilize my skills in GIS, topographic spatial analysis, geologic mapping, and so on. And I'm currently seeking research hours on any funded projects that you may have or potential collaboration on future proposals. So if you have an interest with somebody with my skills, come see me. Thank you.
My principal research activity involves measuring the angular scattering properties of planetary regolith material, a requirement for developing the reflectance and polarization phase functions of solar system bodies, particularly atmospheric solar system bodies, or ASSBs. The problem the community has faced for almost a century is that no theoretical construct or laboratory simulation has been able to explain simultaneously both the reflectance and polarization phase curves. The most outstanding example of this is the data taken on the Galilean satellites first reported by Rosenbusch 20 years ago. To address this, we designed and built the goniometric photopolarimeter, and we've been presenting results to the community. At a meeting on ASSBs last year, we learned that our results were strikingly consistent with theory developed by colleagues in Ukraine and Russia, and were in excellent agreement with astronomical results for ASSBs. We presented papers in both the English and Russian literature, and we're currently measuring lunar regolith analogs being used by Chinese colleagues on the Chang'e 5 mission.
I'm Steve Clifford. My area of interest is water on Mars. Currently involved in a project to look at the hydrologic cycle of water on early Mars, a cold, wet early Mars. That work is being done in conjunction with some global climate modeling by Robin Wordsworth, another model on the development, dynamic and thermodynamic behavior of large ice sheets that's been developed by Ralph Grieve. And I'm handling the groundwater modeling aspect of that. Water is transported through the atmosphere from surface sources to the cold traps where it accumulates in large ice sheets, which can become thick enough to undergo basal melting and recharge a subpermafrost groundwater on Mars, a groundwater system that can in turn replenish surface reservoirs of water like the Northern Ocean. Our results will be summarized later.
I'm Miles Katari. I recently co-authored a paper on inhibition of grain boundary sliding in fine-grained ice by intergranular particles. So you can see here, grain boundary sliding above 6% particulates is basically shut off, and the ice behaves like it flows just through the basal dislocation. You can see that visually here in this very cool cryo-CM image, where the alumina confines the ice grains. And I didn't actually do any of this cool lab or imaging work. What I did do is write the proposal, or half of the proposal that Matt was funded. And also I was like Vince Vaughn in Swingers, because I was the one who said, dude, your results are so money and you don't even know it. Because there are full implications for planetary ice masses, mainly involving much more volatile content. But that's not the main, in things that may be flowing or aren't flowing. But the main takeaway is that if you don't mind me shamelessly taking credit once every 5 years for 10 seconds, then we too can have a successful collaboration.
Hello, I'm Patricia Gregg. My main area of expertise is Mars. I'm a team member on the Chemin instrument on Curiosity. And up there in the upper left, you can see we just drilled our 22nd drill hole, so yay, milestones. This Curiosity is in an area on Mars where we see very high abundances of clay minerals, and those are of particular interest to me anyways, because some colleagues and I have been running experiments about how clay minerals can support microbial life. And so in the lower left there, you can see that's methane production of microbes on clay minerals, and then we've also seen microscale texture and chemical changes in the clay mineral substrate. I'm also a big advocate of education and outreach, and so in the upper right there, that was my summer camp of astrobiology. I taught astrobiology to 6th and 7th graders.
Hi all, I'm Van Putzig. I'm a senior scientist here at PSI. I also manage the PSI Colorado office that we opened in 2016. I wear several hats. I'll describe them briefly. The U.S. lead for the shallow radar on Mars Reconnaissance Orbiter, and as such, head up this group of people that support the operations of the SHARAD instrument and MRO with our facility here in both in Colorado and in Tucson. I'm also involved in a number of research and analysis projects, most of them spinning off of the SHARAD work. Gareth described the SWIM project earlier, so I won't go into that. Here's our large team at PSI, and it's time for me to go, so thank you very much.
Hi, I'm Mike. I work as a computer scientist in the NASA PDS here at PSI, and it's my job to make PDS work better for humans. Because we built this lovely standard that's great for getting computers to understand the data, but I've heard from some humans that it's not so great for them. So, what are we doing about it? OAuth has been completely redesigned from the ground up recently to be much more human-friendly. You fill out pre-formatted spreadsheets instead of writing giant XML labels. you just point and click instead of having to learn the whole standard. And then we're also building a whole new cross-domain PDS-wide search and browse for data sets. So you think about data in terms of targets and missions, data type, things you already think about, and you'll be able to find your data much easier because it should be built for humans, not robots.
Guess I'll take this time to introduce myself. My name is Matt Perry. I'm at the PSI Colorado office. And when I'm not busy with Sherrod and my PhD and the swim project, I'm wearing the t-shirt, I worry about these things called microaggressions. And the reason I'm bringing these up today is because last year at this retreat, I'm sorry to air our dirty laundry on live TV here, but there are a number of microaggressions that I would like to point out in my 1 minute of fame here. And if you all look around the room, there's no one thing that defines what a scientist looks like. And so there should be no reason that somebody walks up to anybody at this retreat and says, whose spouse are you? Whose wife are you? You don't look like a scientist. In 3 specific instances that happened last year, one of these happened twice, is that a gentleman would walk up to a group of colleagues, both mixed genders, and only introduce themselves to the males of the group, which is a problem. You should not be introducing yourselves to the females or other non-binary genders of the group. So if you want to learn some more things about microaggressions, please come find me. As a community, we need to work to be more inclusive. Thank you.
Hello, I'm Bill Feldman, and I'm involved in nuclear spectroscopy, planetary nuclear spectroscopy. And we've been lucky to be on 4 missions. The first to the moon, which was Lunar Prospector. The second one to, well, let me see. The second one was to Mars, I guess. And we, that one failed because it just went right by Mars and never stopped. But we have one that was launched on April 7th. This is Mars Odyssey. And it was supposed to last for 3 years, and it's been now over 17 years. And we're very happy with that. And this did, and then one was to Mercury, and then one was to the asteroids oops, okay.
I'll talk to everybody later.
Hi everybody, I'm Steve Scheidt. I'm an associate research scientist. I started with PSI last year. I've been working with David Crown here for a little while, specifically on mapping geology of Mars. But by and large, I'm kind of a terrestrial geologist, and I provide air support for a number of projects, both at Goddard Space Flight Center and actually mostly them. Yeah, we went to Iceland this past summer, and up here I've got some slides kind of highlighting. This is a volcanic vent that opened up in 2014, a fissure vent, and put out a number of different flows. This is a digital terrain model that I created from UAV photos using this system. It's a fixed-wing aircraft, DGPS. There was supposed to be a beautiful video playing here. Mostly I use this little guy, and I like to collect images of things that are below the resolution of most instruments. Thanks.
Hello, I'm Amara Gropp, Senior Scientist at PSI since 2012. I'm here to tell you about 2 passion projects I recently developed. First is the ELF Climate Change CubeSat STEM project that is a €2 million proposal to the European Commission Science with and for Society program. It didn't win on its first round. We will try again next year, and I'm here to tell you about this project because it can scale to other locations. So on the ground, we use Raspberry Pis, smartphones, and a CubeSat. And if anyone thinks that this US PSI-based project is interesting, please come talk to me. Next is my in-space resource utilization passion interest, where I help policymakers and asteroid scientists. Why? Well, there are 800 scientists in the world and a few asteroid mining companies, and we would like them to talk and work with each other better.
So I'm not Eli's flute, but she was unable to come because her dog was sick. So
Aww.
Since I'm a collaborator on these projects, I'll tell you a little bit about what Eli is doing. This summer, she's been working on with some undergraduates on a project involving the spectroscopy and kinetics of amorphous salts on Mars. She's also been working with me on an exobiology project in which we are growing microbes on nanophase iron oxides and looking at the bio and non-bio reduced products. Thank you.
Hi, my name is Tom Grell. I'm a senior scientist here at PSI. This slide is almost exactly the same as last year, and it would have been the same the last, 8 years now or something like that. Working on NEOWISE, it's operating in its 10th year. It was designed for 6 months, so we're very happy about that, doing asteroids, thermal modeling, 8 albedo diameters. The big thing that we're working on is trying to get NeoCam off the ground. We're still in extended phase A, but luckily we have been able to get some funding to continue studying and create some software here at PSI for actually simulating the whole survey to figure out what we can do. And over the last year, we actually crewed a really nice team of people here at PSI. I think we're 8 people on the team now. Tara Lewis, Sarah Sonnet, Ava Lilly, Chun Wu, who we talked yesterday, Yang Lu, who I haven't seen here, but he is at PSI, Joe Kokius, who is a consultant, Edward Grove, who you heard yesterday, and Tim Spart at the FDC. Thank you.
I'm Joe Spitali. I've been mapping eruptions at Enceladus South Pole. I've produced this probability map. You can see the variability is mostly at the edges. I think that this probably reflects the thin ice at the South Pole and basically reflects a direct connection to the ocean, although 1 out of 2 reviewers do not agree with that. There is an object in Saturn's B-ring. We'll take care of that, it's no problem. There's an object in Saturn's B-ring casting a shadow that implies it's about 150 meters tall. Is it a moonlet? Is it an impact cloud? Probably a moonlet, and the bright thing's probably a gravitational disturbance, actually, and not the moonlet. More on that later. And finally, ominous. This completely mission-independent software for astronomical data analysis that I developed during the Cassini mission. This is open source, it's available on GitHub. I personally guarantee this is the best software for astronomical data analysis that has ever been written. That is not a guarantee.
Hi, I'm Amanda Hendricks. My research usually involves using UV and visible spectroscopy to study airless bodies in the solar system, to study their surface composition and processing. And such as on the moon, we're using LRO data to study water on the moon. We are using HST and IUE data to study carbon signatures on C-complex asteroids, and using Cassini data to study weathering effects on the icy moons of Saturn. I'm the PI of the survey node called TREX, based here at PSI, and we're doing all sorts of great things. By the way, that's TREX, not T-Rex. And you can usually find me in Boulder, Colorado, scheming about proposing for new instruments and missions to get more data, and also musing about how to design a self-sustaining settlement on Titan for humans.
Okay, I'm Jesse Stone, and I write software for the Planetary Data System, which archives the data that you create and use. So I've worked on several projects for the PDS, including OLAF, where you can prepare your data for archiving, and the Data Fair, where you can search for archived data. I've worked with I've also helped data providers archive their data. I provide general advice on archiving and data formatting. I evaluate submitted data for standards compliance, and I also write tools to clean up the data before it's archived. I've worked with data providers from several missions, like Hayabusa, Dawn, and OSIRIS-REx, as well as surveys like NEAT, Spacewatch, and Catalina Sky Survey. If you have data that you need to archive, you're not on your own, come talk to us at the PDS and we'll help you out. And if you haven't tried OLAF lately, we've made great changes. Come check it out.
Hi, I'm Henry Shea, and I'm working on a bunch of random things. My main science interests are these things called main belt comets, which appear cometary but orbit in the main asteroid belt. And I'm studying them in a lot of different ways: observations, dynamics, thermal modeling. I'm also involved in preparations for the Large Synoptic Survey Telescope, which has revolutionized our understanding of small body populations. I also have a project to do data mining of wide field archival data from large telescopes. And finally, I'm investigating the dynamical evolution of Themis family asteroids, where the upshot is that there may be contamination of the active Jupiter family comet population by main belt asteroids. In my remaining time, I just want to repeat my plug from last year for people to come join me and Norbert to form PSI Hawaii. Mark has promised to buy us a boat for our office, and he said future retreats can be there if enough of you come. So just putting that out there.
Tedesco. I'm currently working with the Gaia Solar System Science team on helping them calibrate their spectra of 150,000 asteroids that they want to run through a pipeline to come up with taxonomic classifications. My kibitzing goal is to point out to them that solar analogs, which are used to calibrate the spectra, are not all created equal, and so this needs to be taken into account when doing the data analysis.
I'm Elizabeth Jensen, and I study the sun, or as my teenage daughter calls it, the hideous light of the day star. I specialize in studying the invisible, quotes, magnetic field in the vicinity where it's critical to energetics in the solar corona. And I want to put a plug in for my PhD student at University of Southern Queensland who just finished his third and final paper towards graduation. So I'm very excited about that. His name's David Wexler. And I also wanted to point out that this is challenging work. So currently we're applying to do observations with the DSN looking at Parker Solar Probe whenever it's in superior conjunction, which is starting at the end of this week. And our team is, let me give you the list. Of course we have PSI, but then we also have JPL, UCLA, UC Berkeley, NRL, APL, MIT, and of course USQ. This is difficult.
Pasquale Mechanico specializes in orbital dynamics and geophysics, and some recent result had this lower number of large MEOs, which was confirmed by later works. And in 2015, there was a comet flyby by Mars, and we were able to determine the arrival time and the spatial distribution in order for the spacecraft to use Mars as a shield. And more recently, we're studying the series geophysics to determine the reoriented in the past. And we were able to determine the path of the pole, which agrees with the position of a polar equatorial ridge and with the observed crustal fracture, which are created during the reorientation of Ceres. Thank you.
All right, drainage pit craters on asteroids are caused when an extensional fault opens up underneath a overlying regolith layer, where the extensional fault is usually caused by a large impact on the small body. For the past 30 years, it's been recognized that drainage pit diameters and the spacing between them are proportional to the overlying regolith depth, but that has remained an underdeveloped and unutilized technique until now. Recently, Jordan Steckloff and I recognized a very simple trigonometric relationship between the regolith layer depth, its angle of internal friction, and the diameter of the pit crater, and we have applied that technique to two chains of prominent pit craters on the surface of asteroid 2867 Steins, which was flown by the Rosetta spacecraft in 2009. And on this little 5 kilometer diameter asteroid, we find a regolith layer depth of an impressive 145 meters. And our modeling work shows that 145 meters of regolith is currently in a state of equilibrium, where rate of production, regolith loss due to impacts is bye-bye.
Hello, I'm Dorothy Ayler. I've been involved in methane analysis for some years now. And in the last 5 months, there have been several papers that have come out on the subject, and the results are perplexing. First was an independent confirmation of one of the previous methane spikes, but within a few weeks, the trace gas orbiter results came out and they couldn't detect anything. My work has involved the geologic analysis and looking at Earth analogs, and our recent paper suggests that methane releases on Mars, if they exist, are likely to be relatively rare, and they may well be separated in both space and time. That being the case, they would be easy to miss with our style of monitoring that we use right now. So we're suggesting that possibly in the future, smaller, robotic, cheaper landers can be focused on prime areas.
Hi, I'm Larry Lebowski. I'm an education specialist. My area of expertise is small bodies in the solar system. And we do a lot of outreach, et cetera. If you need help, let me know. At the end of the break, we will be doing training on the meteorite kits that are available for you to borrow for periods of time. And also, if you're really interested in very, very, very small solar system bodies, we also have little kits that we are in the process of putting together that we might be able to provide for you people at cost. Thank you.
So, my name is John Warwick, and I build really cool digital elevation models. So, most of what we use is stereophotometry software written by Bob Gaskell. I work closely with Eric Palmer. In the center here, you can see one of our models that was won back in June. On the left is an image, and so you can see pretty much every object that is in the image is in the model. That's what we spend most of our time doing, but we also have a project where we're working on the moon. So we have an L-Rock image on the left and our model on the right. The reason we can do photorealistic models is because we have both, in addition to elevation, we have albedo. And though we don't exclusively study these objects, we have a whole slew of projects in to study Mercury, Large Saturnian satellites, Callisto. And if your favorite object does not have a high digital elevation model, then we can give that to you. Thank you.
Hi, I'm Faith Files. I'm a senior scientist here at PSI, and I'm the director asked me to speak. I said, okay. He said, what do you talk about? I said, or do, and I said, look at small asteroids. He made an overhead for me. I don't think I've ever looked at any of those. I am a telescopic astronomer. I work in spectroreflectance, or reflect light off the surfaces to determine the surface mineralogy of objects. I probably look at the spectral regions that most people don't, which is the visible and the ultraviolet regions. I look at, in particular, at results of aqueous alteration, or the alteration of material by appropriated water. We've had people talking about that related to Mars and asteroids here as well. I also look at the UV, and I'm looking at the effects of the surface of exposure or over a period of time. I haven't totally forgotten what it was I was going to say. And I'm wasting enough time to get hooked off the screen because I really wanted to.
And I'm Mark Sykes, and I've been interested in advanced propulsion technology since putting together a mission using a 100 kilowatt uranium reactor and electric propulsion to put an orbiter around Pluto, but decided to go with New Horizons instead. Yeah. Why is that? But anyway. So a couple weeks ago, I had breakfast with Jeff Grayson, the former founder and president of X-Corps, who was building the Lynx space plane that Faith was going to use for our ATSA project, and he wanted to get us involved in a NASA advanced ideas program thing using a plasma sail to couple a spacecraft with solar wind and accelerate up to hundreds of kilometers a second, over the course of like a day or two. And the target would be, oh, I'm done! Let's go further, damn it!
And that concludes the lightning rounds today from the Planetary Science Institute's retreat here at the Hacienda del Sol in Tucson, Arizona. But don't go anywhere, those of you on Twitch. We will be bringing you today's Daily Space live from the other side of that wall, but we have to get there. So stay tuned, we're going to give you a brief intermission. And as always, remember to subscribe at twitch.tv/CosmoQuestX. And this is a continuing production of the Planetary Science Institute. Thank you. Yes, that would be glorious. Hold on, I just need to switch views. Just a second, I need to clear there. Hello, we are back and we're going to take you on a continuing journey. I'm going to actually let Susie control the camera because I'm holding the computer.
There.
So, welcome everyone. We're taking you on a short tour as we wander to, I kid you not, they have us in the bridal changing room because it is the nearest private room to where we're going.